There is no mobile microphone, so, and I don't like this, so we are a little bit in trouble. So this session is about how to move your DBF, NTX, DBF, CDX based application to the PostgreSQL server. As you may imagine, yesterday we talked about how different these paradigms are in means of accessing the data, comparing ISAM with SQL. And there is a lot of differences between these under the hood, how data is stored, because the way how data is stored is trying to be as optimized for the access method. So a SQL server basically, yes, he uses tables and indexes in an ISAM way, but he stores the information differently than a DBF NTX system because he wants to serve the queries better or differently. So, in this session, I first want to give you some type of introduction into the features, so you have an idea about what you can await from this migration process and the Postgres database engine, and where are the limitations, so to speak. There are very minor limitations, but we'll see. I want to introduce the architecture because the basic architecture of the database engine gives you an idea about different use cases, different scenarios, how you can use this engine. We want to walk through the migration process. We are using here a sample from the standard Xbase installation. It's the MDI demo, a very old traditional demo on the sample collection with just two databases and some indexes. And then we will look into, let's say, conditions and how to use SQL in the context of that, or move on with standard ISAM coding style. So let's start. At first, why did we do all that? Or in other words, what was the reason to do so? Because there is the advantage database. So when I think about I'm having DBF NTX, DBF CDX tables in my application, I already can go to client server. I just need to use the ADS database engine. I have just let up my application in some minor areas such as footers and specifically user-defined functions in index expressions. But then I can go to the ADS server. Maybe I have trouble with OEM chart sets and so on, but okay. But we wanted more. We wanted to have a scalable, reliable, different platforms available for, let's say, as large as possible amount of our customers, a client-server, SQL server-based solution. And so we looked into the market or what's available, and we also looked into how customizable these DBMS systems are. And for technical reasons and for customizability reasons, we finally came to the conclusion that we decided to select the PostgreSQL server system. That's because of its historical roots. The PostgreSQL server has its roots as a research project and basically is in some technical areas still leading or showing where other vendors need to move. For example, one technical part in the system, its capability to, it's called multi-version concurrency control, which is a great feature for SQL systems because normally a SQL system performs isolation by locking the tables or the pages, which means other operations are not possible in this time frame in a simplified view. But with multi-version concurrency control, one party can perform queries, even so another party can perform updates on the same record. And still both parties have a consistent view of the data. That's because a new record in an MVCC system, such as PostgreSQL, is written to a different place than the old record, so to speak. I'm using these terms. And this is great because then users performing queries in the standard isolation behavior can get result sets without being blocked by update transactions. Even though it's a small time frame, when I have my 50 or 100 user scenario where 100 users performing where from these 100 users performing a larger amount of updates, then the others are really hampered by that. Having MVCC, both operations can happen at the same time, and both parties have a consistent and correct view of the data. That's the key. So we carefully selected this system. We also have this situation that many of our customers, or some of our larger customers, more and more ask for a reliable and solid SQL Server solution, which is not ADS for whatever reasons, where it can be reasons such as this was a vertical solution, and the monetary aspect, the means of the licensing scheme, was not attractive. It was also a situation such as scalability, or just the fact that it's not a SQL system, it's an ISAM system, so it's political reasons. But they accepted that they can use the Postgres, so we decided in this context too. Another objective was we wanted to have some type of no-effort move from the traditional ISAM-based storage layers, DBF, NTX, CDX, to a SQL client-server system. And we wanted to have scalability. Another aspect, which is more or less a long-term aspect, I said initially, the PostgreSQL server is very customizable. We use that feature already for the Postgres ISAM emulation to deliver a great experience and performance in that context. Without being able to customize parts of the system, in means of the API layer, we would not be able to deliver a ISAM emulation engine for the Postgres server, such as we are now doing this 2.0 on the conference board. So customizing was critical to us. But it's even more critical to us because when you are working with SQL systems, over time there is the situation that you are moving not much, but some part of the business logic on the server side. This is for simple reasons. For example, you want to have query tools which are using from third parties, which are accessing your DBMS system, and it is not enough to just use the few definitions on the SQL server. So you want to have maybe some additional business logic, or you have a heterogeneous infrastructure where not all the applications are written in Xbase++, maybe in different languages, or your Xbase++ solution is integrating into another solution. So you're ending up in one way or another that you're forced to write stored procedures. Stored procedures have one big problem. First, which is just a learning curve and just a question of costs, means you need to deal with a different language. But the second point with stored procedures is that it is not very comfortable to verify, to test, to debug, to analyze their execution behavior. Because there are tools on the market for different DBMS systems which try to deliver some, let's say, comfortable way to do that. But the truth is, it's still a mess. So there are two things with stored procedures, or basically three. First is different language. We need to learn another language. It's all draws and pitfalls and so on. Drawbacks and pitfalls. Debugging, it's a mess. And the third part is that the more stored procedures I'm moving to the server part, the more CPU and memory resources I'm allocating on the server part, which already is critical in the SQL system because a lot of work is offloaded to the server, to a central place where compared to the ISAM world, a lot of processing power on the workstation is used to gather data or to do some analysis, misanalysis or something like that. So these three issues we wanted to cover too in the long term, and for that again we decided SQL Server because what we did is we added the Xbase++ language as a stored procedural language to the PostgreSQL server, which allows you or us to develop stored procedures in Xbase++. So first part resolved. I can write stored procedures in a language I know. Great thing. Second part, because the debugger will become remote able. I said yesterday it's not yet, it will be in the future, in some future releases. Then the debugging experience becomes greater. But the truth is we have more wider vision in that context, not, which is definitively not becoming real with 2.0 or 3.0, but beyond that. And then you see we are looking a little bit more into the future in the context of the PostgreSQL server, because what we did as a prototype in the early stage 2 years ago, we not only added Xbase++ as a stored procedure language. What we did was we added to the compiler the ability to have the same method of a class once spilled out as native code on the workstation, and otherwise spilled out as a stored procedure code sent over to the remote server. And what that means is, and we can guarantee identical behavior in that context. What that means is the following. I can debug my application completely as a unit, and I can verify my code. And then the tool just transforms this method from, which is running in the local process on my local workstation, to the start procedure on the remote SQL system. And because it's the same language, and because the tool guarantees identity, the verified behavior is guaranteed to work identical on the remote part, which is great. Because then all the massively stored procedures need to learn a different language, and the debugging aspect is finally resolved in that context. It goes even further. Research has shown, not only by us, but done at some universities, that by doing the following, it's called instrumentation, it's called random instrumentation, you can increase performance in a large-scale installation. The idea is very simple. Let's assume you have the ability that your toolchain can generate dynamically a method which either works on your local workstation or as a stored procedure on a remote system. Let's also assume the system knows by declaration which of the methods in your application are allowed to be freely executed on the client or on the server side. If you have defined this, if the system now starts to randomly, just randomly execute some of these type of methods on the client and others on the server, and by instrumentation measures execution time and workload, the system can dynamically adapt and optimize itself to the most efficient use of server and client resources, which is exactly the requirement we will run into in the next couple of years, I mean of 5 years, 10 years from now. Because we have this dilemma that our lunch, our free lunch is over. I know, how many of you do you know the term free lunch in means of our IT industry? Do you ever have heard that? No? It's a standing term, at least in the research groups, and it's about a simple fact. In the last couple of decades, it was so that each 18 months by Moore's law, processing power and capacities have been increased by 2 times. So each 18 months, we got a free lunch. That means we wrote source code, and for free, without doing anything, things went faster. We could create more and more large, more and more complex systems, and even though we added abstraction and complexity, systems went faster because of Moore's law. Anything went, the processing speed increased, memory sizes increased, hard disk sizes increased. And this lunch, it's called free lunch for software developers, it's over since a couple of years for a simple reason, because of physical reasons. It's light speed, it's high frequency problems, and so on. So what happened is companies seek for ways to work around this, because software development always was behind hardware in that context. And just software, let's say, gained profit from hardware movements. So they came up with the multi-core stuff. But what we have is a situation, we have so much processing power, and we are, until now, not really capable to efficiently use this available processing power on all these different machines in our network and so on. And when I think about SQL, which strictly centralizes anything on a single point of failure, so to speak, possible failure, then it goes even further. We are not using resources efficiently, and it's a question of energy consumption, it's a question of money you put into your IT infrastructure, which you are not using. So this is long term. Let's continue. So the idea was to have stored procedures which automatically move between client and server depending on the infrastructure. which is a perfect solution. Okay, so there have been a lot of very, very good reasons, short-term, long-term, why we finally decided to go with the PostgreSQL because of this idea. Finally, the idea is basically the DBMS system becomes the operating system for my business logic core of my application in a very dynamic manner. What are the features of the Postgres database engine? First of all, primary goal provides full ISAM, index sequential access methods to a SQL database and storage. This is done by caching heuristics, which means the database engine basically selects chunks or pages of data from the server side and caches them inside to create this navigational experience, so to speak. This is done by emulating indexes using stored procedures. When you create a table and when you create indexes, then additional stored procedures get created on the SQL Server, which are used to handle index navigations or emulate index navigation, so to speak. We wanted to have automated upsizing process because right now these applications are based on dbf NTX or dbf CDX files. These are files. And when I move to the SQL Server system, I'm dealing with SQL databases, which means I'm isolated from the storage. I don't care anymore about files. I care about a data model, not about files. It's a total secret, and you should give up to try to understand how the SQL system really stores that information. First, it changes all the time. Second, it's a bunch of files with so many different purposes, forget about it. So what we wanted to have is, we wanted to have a tool which allows to perform the upsize process, which means move your existing DBF tables, the data, to the SQL system, including your index definition and all the other definitions from the ISAM model. We wanted to have this as an automated tool because this is not a task you are clicking together in the IDE environment. It's a task you need to do, and you need to do it very efficiently, finally at your customer sites or at many customer sites. So this tool can be totally automated using XML files. So this entire process can be automated this way. The functionality of this tool is completely implemented in a DLL, which is documented and available, so you can even embed the tool which uses the XML description into your final application for upsizing the data at your customer sites. As always, whenever we add new technologies to the product, we are very sensitive to not break existing behaviors or existing coding patterns. So we always search, and I think we did it very well in the last decades, for ways to integrate new technology by protecting existing investments in means of source code by 100%. That's the idea of Alaska. That's why most of the companies working with our tool are successful in the market, because they don't need to rewrite their application each couple of years or each 18 to 24 months, such as sometimes required with most, if not all, other tools, basically. That means we want to have the ability to use ISAM against this new, against our migrated data, but we also want to provide the experience with SQL. So finally, when you have moved your data to the PostgreSQL server, you can use SQL or you can use ISAM access patterns, methods, and language constructions. It's your choice. You should decide whatever you prefer. And finally, we wanted to have better user experience after more than 3 users or 3-4 users. So when we talk about a single user scenario, it's clear the dbf NTX on your local hard disk is way faster than any SQL server. We don't need to talk about that. When we talk about a 2-user scenario, we are at Pavi. That means right now our tests have shown that the two-user PostgreSQL solution is as fast as a correct installed and configured two-user file-based networking sharing solution. So that party. But when we are going into 3, 4, 5 users, it already starts to dominate on the PostgreSQL side, which means this client-server-based solution is faster than the traditional file sharing approach. And when you start to use, as we talked about yesterday, when you have been in this SQL introductory session, when you start to use SQL features in means of query processing, we can even further increase our performance for the simple reason because we tell the system what we want, and the system can decide what's the efficient way to deliver that information to us. I think those of you which are using the ADS database engine may find this basic layered diagram very identical to the ADS. Point here is that two things. First, as you see here, the communication between the database engine or the client side and between the server side happens over TCP/IP. This already means it's not only your intranet, or you can also use the PostgreSQL server remotely over the internet. We're using a client library. It's like the ACD 32-bit when we want to compare this from Advantage. The difference here is it's the libpqax because the PostgreSQL client library we are using is a special one we created because we added functionality to this client library which is crucial for the ISAM feature set. So you need to use the installation packages delivered, provided by Alaska Software when you deploy your application in means of PostgreSQL. We're talking about the client side, we're not talking about the server side. On the server side, it's just a requirement there needs to be a PostgreSQL server. When we look into this database engine, it's getting more interesting. As you can see here on the top left, there is this ISAM navigational part. And it includes all Xbase DML and DDL functionality ISAM related. Which means any data definition language construct and any data manipulation language construct, DML, data manipulation, DDL, data definition, is supported in the navigational part, the ISAM part. That means your DB create, your use, your skip, your set filter to, your index, your seek, your index on blah blah blah, your set relational, anything works. You don't need to pair. This is true even for the code pages on the CDXs and so on. The other part is the SQL relational, which includes unified SQL and pass-through SQL, which is, as we learned yesterday, the ability to write the same SQL syntax against different DBMS systems, unified SQL, and which allows us to use SQL very efficiently because we can write it as a natural language construct on the PHP level, because we have the SQL language inside the Xbase Business language. And then there is the pass-through SQL, because, for example, the PostgreSQL server has a lot of, let's say, proprietary commands, functionality, which you can use with the pass-through SQL if you like. Which means you can send any SQL command to the server system. Yesterday we also learned a bit about this statement rewriter and side effect analysis, which, how many of you have been in the SQL for Xbase developer session yesterday? Okay, the others not. So this statement rewriter and side effect analysis part, it simply means that any expression, any syntactical construction which you're writing on the language level of Xbase++, it means of SQL statements, is first parsed and then deconstructed, decomposed into, let's say, some type of abstract representation. And then this resulting representation, which can be understood as a code block, is executed in an emulated virtual machine. So there is a virtual machine execution which emulates the operation, and instead of executing the operation, it uses the rewriter of the database engine, which leads to a rewriting, so to speak, of the input expression to a new output expression format, which is then syntactically conforming to what the backend, the SQL Server system awaits. We did that because there's different syntax between different SQL systems, and we want to write the same code in our application because we want to have clean, clear code. We don't want to have to glue strings together to do SQL. We don't want to have if-def Oracle, if-def MySQL, if-def Postgres, if-def whatever. This is non-maintainable code. And then there is the ISAM emulation engine, which is the biggest part, so to say, for the migration process, which basically is a page-based intelligent caching system with a lot of heuristics, with a lot of automatically generated procedures. And there is a native interface to the PostgreSQL server, which is the customized library from us. So, what's the prerequisite to move your existing application to the PostgreSQL system? Of course, it's clear we need to have a server. We don't care which version, as long as it's higher than 8.3. In other words, right now, 8.3 and 8.4, 9.0 and 9.1 are the 4 versions of the PostgreSQL system which are supported. Not only by us, but also by the Postgres group, which is the maintenance group and development group of that system. The 8.3 version was updated the last time on the 17th or the 27th February that year. The same is true for the 9.1 version. What that means is these 4 major product revisions receive updates, fixes and corrections at the same time. This is normal for SQL systems because people don't change, let's say, the version of a DBMS server like people change their t-shirts. What I mean is, when a server system runs, it simply works. And even in some companies, people forgot that there is a server, and they reconstruct buildings and they forgot about the server. Things like that happen. But the truth is, there's a little bit some type of resistance to update a DBMS server, let's say each 6, 12, 18 months. This makes no sense. It's basically only done if there are feature requirements against this server, it means of application requirements in the IT infrastructure. That's the only reason when this happens. Other than that, only other reason is vendor gives up maintenance of that system. This is another point. But normally not. So 8.3 or higher, it's up to you which. What we will do in the final product, which is not with the conference build, we will even provide you our own packaging of the PostgreSQL server. This is because right now the new packages of the SQL server of the Postgres, such as 9.0 and 9.1, they came with a lot of additional stuff, which was designed to make this PostgreSQL system more, let's say, mass compatible for the so-called script kiddies community. It means of competition with PHP, MySQL stacks. This is all a lot of crazy stuff which really a lot of business application developers definitively not want to have installed. And it just creates a lot of confusion in the installation process. It adds a lot of additional stuff which is not required. It even adds additional stored procedure languages, which nobody knows, but they're great to play with. So it's just overhead for nothing. So we will repackage 9.1, 9.0, and add these packages to the product to have just the server with all the installation features which make sense. Operating system, we don't care too. That means as long as the SQL Server is connected to the TCP/IP network, you can connect to it. If it's Linux, Windows, or whatever. I mean, the SQL system, PostgreSQL is available on different operating systems, not only Linux and Windows. But if you plan to have the ability in the long term, so to speak, to move to stored procedures and maybe stored procedures written in Xbase++, we have right now no plans to support Linux and other operating systems right now. So it should be considered that Windows therefore is first choice if you want to move into that direction long term. Okay, that's now. Network, I already said, you can use it in a LAN in a WAN environment. And this is important to realize the differences. You know, in a LAN, we have a lot of bandwidth, no problem, because it's 1 gigabit. In a LAN, we have a low latency. That means when I send a packet to another workstation from the client to the server, the latency is typically under 1 millisecond. If it's bad active components, it's maybe higher. Depends on the quality of your cabling. If your cabling is broken, it can even take seconds or minutes, you know. But with a WAN, the thing is different. WANs, typically, even the expensive ones, or typically, they have very good bandwidth. So we really don't need to care about bandwidth when you talk about WAN. But we need to take care on the latency issue. Because latency, the time the data packet needs to travel from the client to the server to send the question, and then back the packet from the server to the client to receive the answer. If this time is too large, we cannot send many requests to the client, to the server. For example, with the ISAM, I'm basically sending with each navigational operation a request to the server, even if I use client server. Sure, because I'm sending the request to navigate such as C or skip and so on to the server. That means the time for 10 skips or 10 seek operations is 10 times the latency multiplied by 2, because I have the send and the receive operation. So we have in our, so when we talk about the WAN, where the latency, for example, is 50, 100, 200 milliseconds, then we can do 5 skips in a second. Oops, this is bad. So using a ISAM, a navigational data access pattern over a WAN, it's a thing you should not do. It's not working very well, really. You can do tricks and do that, but in fact it's not working very well. Now let's remember, SQL, it's about result set oriented operations. It's about sets. That means I don't navigate from one record to another on the SQL server. I just tell the SQL server I want this, and the SQL server sends me back the result set in one bunch, so to speak. Simplified view, but in one bunch. That means we have to get our set of all 10 records, which in the ISAM we need to skip through. We get this result set in one request reply pattern, which means at 1 multiplied by latency multiplied by 2, not 10, means 200 milliseconds. Works well in one. And if the data is larger, we don't need to care. It's just a bandwidth question, it's not a latency question. That's the important part. It's not a latency question, it's only bandwidth. And this makes the SQL system, in that case, very efficient even in a WAN scenario. Where we have low latency, high latency, and high bandwidth. So you can use it, it works very well. So, next part of the session is more practical. I need to check my, at 12:30 it's finished.
Whenever you finish, it's finished.
Whenever I finish, it's finished, yes, yes. But I'm now hungry and so on, so. Okay, just an orientation. Basically, we're now starting with, let's say, the practical part. It means of we want to move the MDI demo to the PostgreSQL server. To do so, there's some type of process required, because in the first step, we need to have the PostgreSQL server installed. It's clear, so that's number one, preparation. Install PostgreSQL server and verify installation. Here it starts. When I have installed the SQL server, I need to do the verification. For that, simple task. Okay. Tools. When you have installed the PostgreSQL server, there's also installed a tool. It's called PQ-admin for PostgreSQL Server Administration or Administrative Front End. And on my workstation, I have installed on the local host, which is the default, the SQL server. And when I can connect on it, or can connect to it, by double-clicking on this node, and I can't change the font size here, so I'm sorry for the back rows, then I'm at least able to successfully connect to this DBMS system. It's available and so on. I think Till in his session about the SQL Server should have talked about that already, and also about the network issues, so we don't care about this. We can assume we have been able to install it and verify the installation, even accessible on our network. So after we have done that, we should have a look into our application which we want to migrate. For this, oops. I have used the MDI demo from the normal sample installation of Xbase++. It has basically the customer table and the parts table, where the customer table has NTX indexes associated. It's cust A and cust B NTX. And the parts table, it's a FoxPro table, which has CDX indexes associated with. That's the thing. Just rebuild that application and start it. So you may remember that. It's that very simple application with some bitmaps and the parts and customer thing. And I can go to host room, I can perform the seek, go B, copy, go down, select, and so on. That's a simple application. First step in the migration process, slideshow, form current. First step, we need to determine tables, indexes, and use database engines. We already did that right now implicitly. It's the DBF NTX because of the customers table, and it's the DBF CDX because the Fox CDX because of the FoxPro tables with the images in, and the CDX index. So the next step is we need to set up the upsize configuration file. To do this, let's look into that. As I initially mentioned, the upsize configuration file is basically an XML file. I have it here in the Xbase++, the code editor. And in the first step, it's a config section. It starts with defining the used database engines for the upsize process, because there can be many different database engines involved. There you can build your own database engines by combining and doing your configuration, and you need to do that here too. And for that you can use this database engines definition part. In our context, okay, we know we need the DBF index, and there's no special configuration made, so we just define the DBF index database engine, and we need to use the DBF CDX, which is a database engine built from the Fox DBA and the CDX DBA, so we do that too. And because we want to move our data to the PostgreSQL server, we load the Postgres database engine. That's it. So in means of database engines, we're fine. Next part, we define the connection to the remote data source or remote data target, to be more precise in our context. For that, we define connection. We gave this connection a free name. It's whatever we think it's feasible in our context. We refer to the database engine used to establish the connection. If I would have loaded here the ODBC or the ADS database engine, I would here can use these engines and then connect to a remote data source, which I maybe want to migrate over to the SQL server, if I want, to the PostgreSQL. Okay, here the server name, in our case it's localhost. Of course, user ID and password is very secure on my machine. It's Postgres. And I need to name the database because the idea of the upsize process is that all the tables or the indexes which we are defining in this file finally create a database. And so we give this database a name. We learned in our SQL for beginners or explicit developers session that a database is a collection of tables. In our understanding, a database is also a collection of tables and index definitions because we know about performance requirements, which are typically for SQL developers not so well known at first step. Okay, and then we come to something which is called a table definition. It's line 30 through 35 here. And we will first say table name is customer. That's the name we gave it on the target. It's managed by the DBF index database engine. Its DBF table data source, it's data customer DBF, and its orders are defined here. So this is just referring to the physical files because we are updating ISAM. So the same continues a little bit aligned down here. With here. And then we have on line 43 and 44 the most simplified definition of the upsize process. We want to have upsized the table customer, which is defined here, or here the table part defined here, to the connection test, which we initially defined, remember, in a mode which is called ISAM. There are two upsize modes available. There's ISAM and SQL. In SQL upsize mode, the system just moves your data from one data source to another one. It doesn't change your schema. So it completely leaves the structure definition, so to speak, from your source tables intact and doesn't change them to the target tables. It does not touch them. In this ISAM mode, it does a lot more, so to say. So when we have set up for our application this data model, then we just let it run. For that, I can just click on the file. Oops. It's already done. So what I did, I just started the upsizing process on this upsize definition, and the system loaded the configuration of database engine, was able to perform the basic configuration, started to prepare for the upsizing process, which means that the tool verifies not the syntax but the semantics of your definitions. Is the deep database engine in this table definition available? Is for that upsize process the table definition available? Are the files openable for this table definition, and so on? Is anything available? That is meant when it talks about preparing. And then it finally says prepare successful. That means after that point, the system is able to perform the upsize process completely and successfully. If not, it always rolls back, so there is not some incomplete data on the server side or some parts. It's all or nothing. You can change this mode, but by default it's all or nothing. And then, okay, it creates our tables on the backend side and transfers, after creating the data model, it transfers the data, and finally it starts to create the indexes, and that's it. Not very spectacular, but when we close this, and look into the result, or maybe I should open databases. Just let me drop that database to ensure. So now this database has been removed from the MDI demo. So close that. Upsizing tool. Please always. Okay, done. About this upsizing tool, this tool automatically identifies the workload on the server. So it's feasible. It's designed to even perform upsizes of large amounts of data, because what it does is it knows the saturation of the SQL server, and depending on the amount of data in your tables, it creates new threads and partitions the input data and uses different threads to send the partitions over to the SQL system. Because it knows the saturation, it can exactly balance how many threads it needs to saturate our SQL server for the update of the access process. If you have physical access to the DBMS, to the Postgres server or something like that, you can also create a SQL file, which is just a large ASCII file, to be precise, a large UTF-8 file, which you then can load into the server on the physical machine, so you don't need to go over a network. This approach is then feasible when you have very, very big amounts of data. With large amounts of data, I talk about, let's say, hundreds or thousands of megabytes. I'm not talking about 50 megabytes or something like this. Okay, upsize done. We want to look at this. Now we just do a refresh, and here's the MDI demo, we remember, yeah?
Can you migrate data on open data from the source tables? Can you do this?
You mean the
tables are open?
The source tables are open. Yes, they are. That's possible. The only thing is you should to keep in mind that you eventually in a situation where you are upsizing inconsistent data because some mutations are running on your source table. But the system you can have this in the table definition. By default, it's exclusive, but you can allow it to open shared. So, and the good thing is you have total control about all these things if you use the API, so to speak, for that. Because what happens in fact is the upsizing tool loads this XML configuration, and the XML configuration leads just to instantiation of classes, and these will be documented in the file release, so you can even derive your own classes from these upsizing classes and do whatever you want. So back to this, we have dropped the database, now we have back the database, MDI demo. Let's go into the schema here.
Can you also migrate partly?
What do you mean with partly?
Some tables one time and other tables
yes, sure, but that's the whole idea of the system, because what we have here is we have the ability to move. His question was about, can I just move a part of my DBF NTX tables of my existing application to the SQL server and leave the rest, let's say, on the ISAM world, in means of storage, not coding style storage. Yes, of course, that's one of the design requirements we had in the early stage, because It has turned out in the early days when people used Xbase++, that one of the big features was that they were able to have the Clipper solution and the Xbase++ solution have running concurrently against the same data in the same network, blah blah. And the same is true here. So when you have a large ERP or a large whatever solution, you can take just the part which is in the first step important for you and move it to the PostgreSQL and leave all the other stuff on the ISAM. Because initially I said we never break with the past. When we put new technology into the product, we always integrate with existing technology, which means what he wants, it's exactly possible. That's important for us. Now let's look into the left side. We have now a total of 5 tables. While the first 3 tables are implicit, they are not related to what we upsized. It's Alaska Software, ISAM orders, ISAM tables, and system connections. These are meta tables which you can find or which you will find in any database which is used in an ISAM way on the PostgreSQL server. And they are required to handle, for example, things such as log states of tables, because we want to have flog, for example. They are also used to record things such as record count, or they are used to monitor things such as last update date, because this is typically not monitored. And a lot of other meta information such as the complete meta definition of the indexes, index expression, for expression, whatever. So when you look into them,
Steffen,
yeah,
you said you use it because you could have, for example, flog.
yeah.
Does it mean you can use it to log a table
Exactly.
from Xbase++?
Yeah.
Oh, great.
I initially said all ISAM data manipulation and data definition functions and commands are available on the PostgreSQL server, and that includes logging behavior too. It goes even further. The logging behavior in the ISAM emulation on the Postgres is much more efficient than the logging mechanism used on the file system based. That's because initially, in the first prototype, we implemented the logging by having an additional flag in the record. And then we had some other flags in the meta table definitions for this. But it turned out that this is a very bad idea, because that would mean if one workstation in the network has logged that record, I'm talking here about a SQL row, and this is manifested in this row by setting this log flag. Other workstations only can try to acquire the log of that row by performing a select operation against that row and verify the log, which means all other workstations would pull. And that's exactly the horrible scenario the file system suffers from, because client workstations get not notified, they all need to pull. And so a lot of useless and senseless resources are allocated for pulling the logged state of the file or the record in DBF tables on hard disk. And the naive implementation in the SQL system would be have a log flag too. But it's not working because it creates race conditions in means of all client workstations would try to acquire this record by trying to verify all the time if this field has changed, which means all client workstations in the network would pull. What we have here is for the logging is the following. We still have this logged flag. That means there is this additional flag on the row which says this record is logged or it's not logged. But this flag is only used, so to speak, for the to manifest that there is a log on that row. The logging communication between our client workstations and the network works based on a peer-to-peer network, which means when a client workstation in this ISAM emulation wants to log a record, it first tries to acquire the log. And if the log is already set, it just gets added to a notification list, which then this party, which already owns the log, which then frees the log of the record, sends a notification to all other stations which wanted to have a log. This is push. This is perfect. Because there's another hidden benefit in this. This solution is fair because this queue of the order of incoming requests is worked through by the party which performs the unlock operation in reverse order. That means in the order the incoming request was coming, the reverse order, the workstation can get access. When you remember, one of the biggest problems we have when it comes to record locking and ISAM behavior on file systems is that there is this race condition and competition against the log. One big point. All workstations always are in a race who can acquire the log first. And we know that the workstations which are near to the server, so to speak, physically, have a higher chance, probability to acquire logs at once, which are behind, for example, another switch. Which means the performance of the workstations near at a server room is higher than the performance of the other ones. This is poor reality in this world. This all cannot happen because it's fair. Huh?
This is a pretty smart idea to handle this that way, but what are you doing with a client workstation that crashes when the record is locked?
Oh, that's where
you turn the flag back.
this is done automatically because, for example, let's say if in this scenario the client workstation crashes and does not resolve a session, that's exactly why there is this meta table here. Oops, we have a meta table, another one. It's about connections. And the connection table not only collects which clients are connected, the connection table and the server and the client establish a I'm alive protocol, in fact. That means the system knows when a client goes down. After some period of time, it's in fact 10 milliseconds, something like that. So it knows when it goes down, the connection can be removed from the connection pool, and associated logs get automatically removed too, because it's a rule in the data model. That's the good thing here. So there are a lot of things here by hidden triggers and stored procedures, which done this work behind the scenes, so to speak. But very good question. What happens if a workstation crashes in that scenario? Yes, we realized these problems in the early design stage too, it's clear. So back, the truth is that we have also, in terms of your question, we have complete locking behavior and semantics, record or file locking, and we even have it in a much more fair and efficient manner than we ever had it with the DBF tables on the hard disk. And that's the purpose of these three meta tables. So there is this one for the, this is orders, which just has the tag, the bag, which is a very known term. One moment. It has the for expression, it has the key expression, it has the key column. And here it starts to become very, very interesting. Yes, please?
Does alter table statement reflecting on this meta tables?
Not yet. Not yet. But it's not necessarily because when you perform an alter statement, you as long as you don't, let's say, change the type of your index expression involved column, you can perform alter tables as much as you want on this. Because we don't forbid to change the schema of these tables. It's totally legal to change the schema. It's not legal to change some parts of the schema, which I can show later on, or we will see later on. Let's start with this here. We have here the key expression. It's very simple. It's abo last name plus first name. And then we have key column name. That's how indexes are working on the SQL system. Because an index in the ISAM world is not comparable and cannot be compared with an index on the SQL world. It's totally two different things. Same name, two things. In SQL, indexes are just there for performance reasons. So they're nothing more or less than a more efficient, fast path to specific data. That's it. In ISAM, we are using indexes for two other purposes. We're not using indexes for performance reasons. We are using indexes to create orders, first thing. So to establish a logical order on top of a physical order of our data. Second part is we create with our indexes so-called calculated or surrogate values. So some complex index expressions with user-defined functions create very, very weird, difficult artificial keys based on which we have very efficient search, sub-search, sub-select capabilities on our ISAM data access pattern. Because we want to continue encoding on that, we need to have the indexes with the Postgres ISAM emulation too. But the good thing is, an index in the ISAM world is nothing more than a column in the SQL world. So the good thing is, what the upsizing process does is, he adds for each index in the back an additional column to our table. And the index expressions are also stored here, but because these index expressions are executed on the client side, that's the interesting part here, we can also use user-defined functions in our index expressions if we want. Because indexes in SQL are just columns, and I mean the value of columns is always coming on the insert and update statement from the client side. So it's perfectly fitting into that picture that we can have any type of data, any complex construction of data using user-defined functions for our index value. That way, we also have user-defined functions for indexes, which unfortunately was never possible with the ADS for technical reasons here. The same is true for for classes. There are other such information such as table names, IDs, key lengths, decimals, key attributes, and so on. It's when you look into the table, okay, we have here a couple of things. We have first, this is the meta database which describes our tables. We have first the table name on the left, and then the UNC name. The UNC name is the following. When we are upsizing our data source, then this data source has a location on the hard disk. And very often people have the same tables in different subdirectories for solutions which are able to handle different Mandantensysteme, it's the German term. So you can have different clients in the same application, and to do so you have different subdirectories such as client 1, client 2, client 3. So the truth is we have different subdirectories but same table names. So how to move this to the system? I mean, in theory it's very practical. We have a database for client 1 and a database for client 2. That would be the way in the first step. But some people also have created applications which have this type of data organization, not for different clients, but for, let's say, different types of data in the same application. So we have identical table names. So we need to have a further way to qualify the name on the table. And that's the reason why the original location is completely inside, because then the system can expand the name qualification. That's the whole thing. And then we have clear, updated and created timestamps, which is a benefit now. Old functions only allowed us to determine the last update. Now we have it exactly as a timestamp, and we have the creation time, so we have both. We have the amount of records, the amount of updates, and the current ID of the log owner, which is the current session ID and the session table of the current log owner of this table. So, and then there are our original tables. When we remember, we have this customer table. Just look. No. I definitively cannot change the font size in this tool. I'm sorry for those. So what we have here is it's the original customer table. I mean, from here to here, it's just a one-to-one mapping of what is coming from the DBF table, which means the character 6 is still character 6, 20, blah, blah, blah. The logical became Boolean. It's not a fun thing. PostgreSQL has the Boolean type. Other SQL systems have no Boolean type. It's in my session yesterday I talked about standards in SQL. It's one of these nice things which the vendors on the standard committee could not agree to have the Boolean data type as a requirement for all systems. So it's an optional, you can implement, but you don't need to implement. So there are many SQL Server systems out which don't have Boolean or logical as a data type. It's not a problem, people use them numerics, characters, whatever. Okay, and then text, which is like the memo. And then we have these type of columns, which have leading underscore. When you are open these tables with the Postgres engine, you don't see these fields. So if your fields have a double underscore underscore, they are not visible on the ISAM level. And what we have here, it's clear. First we have a deleted state. This is because yesterday we learned there is a delete statement in SQL, but it's a delete statement. There is no record. When we want to have ISAM capabilities, we want to have the ability to perform the delete and to perform the recall operation. There's the record number, right? Because in SQL there is no record number. I have a primary key on my table. I don't have a record number, but we want to have this guarantee of record IDs. We want to perform a DB-goto. We want to do a seek to a specific location. We want to remember the record number as a unique ID to this row. And then we want to go to this, or to jump to this record IDs, because we are, for example, implementing a tree navigation with left, right siblings and things like that, which SQL people drives crazy. We need to have the records, so we have them. Then we have two things which are internal. It's row version and key version. This is by the engine required because there's the row. And we learned when we have indexes, there are additional columns inside our row which are for the representation of the index value. What happens if now somebody using an SQL system and writing SQL code performs an update on our row, which of course means he is not updating our keys, our columns? Well, not a big problem, because this table has a trigger associated. If somebody using SQL statements in this front end or an ODBC driver or whatever performs an update on the customer table on the record, the record's row version gets increased automatically. They can't avoid that. And the next time the Xbase application visits that, or your application visits this row, and it identifies a mismatch between the row and the key version, it just re-evaluates the key values and performs an implicit update on the key values. That's it. There's even a automatic recovery mode, so you can open a table and enforce a complete verification of the table. It means it opens up the table and guarantees you that when the table has been opened, row and key versions are matching. So there's automatically anything done when you use the table. This is a good idea to have the tables open in that mode when you have a lot of integration, because SQL and between your application and foreign applications from other parties which don't use ISAM access. So that's why there's this row and key versioning scheme. There's the log owner, it's on the row level. Previously we have seen there's the log owner, which is the session ID for the table. We also have a log owner for the record. But this is just the owner. He writes his own session ID when he gets the log. And all other ones are using this peer-to-peer communication, which is very efficient. And then we have these calculated fields which are reflecting the values of the index columns, which we have added.
Can you use this log owner for internal things?
Yes, yes, you can do.
Which users
Well,
log this right?
Yeah, sure, because what you can do is you can use this log owner ID on your record and create a query. Okay, I have no connection, but and then I see username, workstation, and process ID. So this is perfect, and connection ID. So it's a simple select query because you just need to do select star from okay, select username and workstation ID from Alaska.system.connections where connection ID equals log owner. That's it. And you got it. So easy it is. And then you have the log owner of this record or of the table. And that's a good thing with these data models, and that's why we decided to have it as a transparent meta model on top of it, because then it's documented and you can use against, and you can use SQL against this meta level of your ISAM tables to do things such as identification of log owners and sending them a message or disconnecting them because you don't like them. The same is true for the parts table. The little difference is the parts table has an image, which was the field bitmap image, which is byte array. That's the type name on the PostgreSQL server for binary data. It's an array of bytes. Here we see some triggers which have been created automatically to monitor changes on our parts table. So this is a trigger which happens after any update on the parts table, and it just increases the row version, basically. So whenever somebody executes a SQL statement which changes data of your table, the row version gets automatically updated. And this way you can identify somebody else has changed. Then there is this table data update trigger. So if somebody performs an insert update or delete operation against our parts table, then we execute a start procedure which updates the meta information on the table. We remember in the meta part of about the table, we have things such as last update dates. We have things such as record count. So we want to have them updated, even so somebody is using SQL in a different application and it's appending data to this table. We want to have it automatically behave such as ISAM data again. And so there are automatically some triggers. Beyond these triggers, there have been some additional start procedures created in the system which are not related to the table, they are free, which are created for each index, and these start procedures are used to mimic last seek behavior against your ISAM data. It's used by the engine itself, but it also can be used by some SQL developer if he wants to have the same matching pattern, because these start procedures also reflect the behavior in terms of code pages. remember, we have this fact that by changing code pages on indexes, it becomes case sensitive, case insensitive. It develops different types of orderings in seek or in soft seeks, which we use to efficiently find data we want. But we want to have this type of behavior on the SQL system again, and for that, these additional seek procedures or seek start procedures have been added on a per table, per index base. You see parts, part name, seek. So that's the table, that's the index order, the related seek operation. And then there's okay, this is not so. Okay, so much about the upsize process, which is beyond the complete implementation of the Postgres database engine, basically the major part of the entire process. Because next step would be we have successfully moved our data to the SQL Server. I mean, let's have a look into tools. Let me start it. Again. Choop. Choop. Do we have customers ongoing? No, English database, sorry. But you see we have this data from the DBF table now on the PostgreSQL side. Where and we can look for somebody in Austin as a city. So next step would be we need to change our application. For that, we first need to add the connection to the database. It's clear we need to connect to the PostgreSQL server. We need to, in our case, we also need to connect to the database MDI demo because we moved our data to the MDI demo database. And then we need to review the source code of our application. I will do that for two reasons. The first reason why we need to review the source code of our application is because sometimes you have code which uses the file function to verify if a file, such as an index or a table, is there. Remember, it's about ISAM. And you need to review your code and find these. And if you found that type of code, you can use a function like isTable, and you can put the session and the table name here, and then it tells you if this table is available. So get rid of the file, use isTable or isorder, because both are working now with ISAM, DBF Intix, and so on. Just leave the session empty and enter customer, and it uses the current database engine and its functionality to verify if this table is available or not. So this is the first part you need to do, because this is checking for files which are in the Postgres scenario are no more existing. And then there's the second part which you need to find. Sometimes in your code you explicitly write down with a via clause which database engine is used. In our case here, the original code was use part new via FoxCDX. because we are now with the PostgreSQL, we need to remove that. Otherwise, we would force still the use statement to use that database engine instead of our connection. The best way would be if I would write here this and would have the session passed in. But I didn't want to do that to create another complexity. In this sample application, we have just one session to our Postgres server. I don't need to have that exclamation. I can leave that out, and the use operation automatically uses the current session of the active session of the current thread, which is in our context the Postgres session we did.
Can you have more than one session open in
Yeah.
the same thread?
Yes, you can
Then
have.
you will need to have it.
Then you will need to have it, exactly. But in our case, we just have one, so we don't need to have it. I can have an infinite amount of sessions open, but I always should remember I never should use sessions over different threads. One session per thread, but not a session from different threads, because in SQL Server or client-server systems, session encapsulates transaction context. And if sessions are shaped between threads, oops, transaction contexts get moved between threads, and this is not so funny. I mean, thread A does abort, and thread B, oops, abort too. So, okay, that's all. That's all I need to do. In our case, I also need to the demo, which I did. I just need to then use that define, because now it's Postgres define and we have that code path running. These are the entire changes. I mean, this is page up, page down. It's not valid for my _PG change. This is the define I enabled. This is for the connection. This is the place where I removed the file, if file exists with this table, and that's the place where I change the VIA clause. And now I just do this, recompile. No, I just need. I need to close. Yes. Recompile the application. I start the application. It starts with Postgres enabled, because I have here in the demo, I have here this message box, which is a proof we're in the right context. So I go to customer. I can scroll. I go to parts. We have our images also moved over to the PostgreSQL server. I can do that. I can go to my seek operation, seek for the B, charge. He is in Baltimore, and because it's hell, it's Mr. So, Mr. Bushboy, whatever. You know better. So we go back to here.
George Bush.
George Bush.
Yeah. And Baltimore. And we have Mr. instead of Hal before. That's it. So we move the data. That was the major part. And the adoption of the application in this simple case was not so much, but the truth is, this is really, at least until our current knowledge, the only two things. It's the file part with your file function where I check if this exists or not, and it's the other part with the VIA clause. Anything else can, in your application, stay as it is, recompile it, add the connection, and feel good. That's it. And it goes even further. I mean, you can have now new features. I mean, we talked about this upsize process, we talked about bin. It goes further because now we can have user-defined functions in our indexes and filters if we want. That's the first plus. The second plus is we don't have to deal with this OAM issue anymore, because What happens in the upsizing process, and that's for those of you interested which are doing international applications, with 2.0, the storage format in context of the PostgreSQL server, but also in context of the universal SQL storage inside memory, as in-memory storage, and on disk in means of SQLite database. It's UTF-8, it's Unicode. So we don't have to deal anymore with this OEM ANSI Kladderadatsch here, where, for example, with the ADS server, we can't reliably store OEM characters because it's an ANSI system and it always converts. This is now history. We can really store original OEM data in the PostgreSQL system without any harm, because we have a UTF-8 Unicode storage. So all these international issues with diacritical characters which are mismatching between different installations when using the same storage, this is by definition history. Which is another class, at least for us Europeans. Full screen. Okay. So, are there some questions about this process and the capabilities? Yeah?
Sorry, is this functionality integrated in the conference group also?
Exactly. Anything I've shown right now and any summary I've shown, I will also put on this server, so you can try it out with the conference build. I use the conference build here, even though I use the debug version, because I have a different environment on my laptop. I prefer to use the debug version, which is slower than what you have, but behaves identical. So, yeah.
What is the overhead of ISAM compatibility for the PostgreSQL database system?
Not so much, because almost, the point is, the overhead, when we think about the fact, when we think about the metadata model, then we have overhead in two areas. It's first, this implicit overhead to have these indexes, these index columns, and because the ISAM accesses, or we are using via the ISAM, these index columns, very often it makes sense to have them also declared as an index on the server side to increase performance. This is not done automatically. You need to decide to do that. And this creates overhead for your update transactions because you have another index. That's one overhead. The other overhead is the overhead with these triggers, which create pressure on the server side when you are updating one. But it does affect the overall update performance, and we're just talking about overhead in terms of update, delete, insert statements, around in a range of 5 to 10%, so you don't need to care really about this. It's not dramatically. We have been very sensitive on that issue, specifically when you remember my talk about the locking behavior, where we designed a complete different system isolated from the SQL Server to avoid this issue that we overbook the SQL Server, because SQL servers are sensitive to that, and we wanted to avoid that. Yes, Rachel? Oh, sorry.
How much documentation is on this release that we're getting?
The pictures I used here in this in my slides, these black-gray pictures I grabbed from the documentation.
Okay.
So all these pictures are in the documentation. Most of them have been also documented with text. There's also in the documentation a specific chapter which I really would say you need to read through it. It's about data types on the SQL system. We will talk about this in the advanced SQL session tomorrow, I think, because the data type is a whole story by itself, so to speak. And we wrote a dedicated chapter about best practices, how to select under which conditions which data type, and which things you should ignore when selecting data type. Many people try to select data types based on performance characteristics they know about their database systems. But the truth is, most of these are just assumptions of people that think they know. And the other fact is that most of these assumptions are always broken over time. So, as always, optimization up front is a bad idea. It's not working. You.
Yes, often in my applications, at a later point, the organisation might want to say, who actually entered that piece of information? Can you use the metadata for that?
You can use the metadata, but in a SQL Server system, you do that in a quite different way. Let's say you want to have monitored any changes to your invoice table, because you don't trust your people in your company,
Yes, that's what it is,
and you think they're changing the amounts and doing little tricks. It's easy, because you can add a update and insert, or let's say an update trigger, or update and trigger on update and deletes. And in this trigger, you take the old data and the new data and record the changes in a different table. We call it invoice record changes, whatever. And you can even add different complexities to this approach. So it's not a question of the application. This is a typical task which you are offloading to the SQL Server using triggers. Normally this is called auditing. Many systems have these type of data models behind the real data. It's for auditing and revision. Yeah? Some other questions? No? So I want to conclude. As we have seen, it's very easy to move our existing applications to a SQL client server architecture using the PostgreSQL engine, because it basically does the job for us. It provides us all the ISAM functionality. We have an Upsizing Tool, which allows us to move our data to the PostgreSQL server. So we are all set, and in fact we can save a lot of money at our customer sites. Specifically when I'm doing vertical solution development, because I now have a reliable solution which scales from the customers I have with 1 or 2 workstations up to customers with hundreds of workstations. And that's a good thing for me as a developer. I don't need to care and differentiate between these type of customers anymore. This is great because one source fits all in theory. Our new code, and that's a cool thing again, we can continue working with ISAM. So we can sell SQL applications and just coding as we coded the last 10 years. We don't care, and we don't think that this will be any problem, except maybe you're writing a lot of code which is not required, because, you learned yesterday, in some areas it makes sense to use SQL instead of ISAM access. Namely, specifically when we talk about query processing and things like that, because with this declarative manner, talking about what I want instead of how I do this thing, it's more efficient. But you can do both. We can write ISAM code, we can write SQL code against this database, so we are happy. Unified SQL, I said it, allows us now the transparent access to the SQL level. With PostgreSQL, I mentioned yesterday, we can even use proprietary features Alaska have not thought about in that context. So again, the idea of the product, mission accomplished, when after 2.0 is released. Existing investments have been protected again for the next wave of whatever changes will come to us.
Stefan, one more thing. One of the consequences I heard of is if I display a parts screen and several things of a part actually refer to different tables, and I start then browsing through my parts, there are so many requests in this way going to the server that the server actually breaks down on the number of requests.
I don't see that many requests, because what happens is, let's assume the following. We have a 1-to-n relationship with a degree of 3 or 4, which means there is table A pointing to B, B pointing to C, C to D, and so on. And we want to have all that into one browse, for example. So what can you do? You have these tables as ISAM tables. Then okay, you use it as before, because the point is the seek operation first tries to find the data in the local cache and then goes to the server. And the data is in pages collected from the server, and in an intelligent caching system with heuristics and a timeout, so to speak, managed on the client workstation. So that means when I have this browser, which is the aggregated view from 5 different tables, it does not mean when I scroll up and down, I even have a single request against the SQL Server. I have one or multiple requests against the SQL Server each 500 milliseconds or each second, but not multiple requests per the same time frame.
It's actually different. You're looking to your edit screen of your parts, your display screen of your parts, and several parts items are looking at descriptions in different tables.
Yeah.
So, I mean, for every part you display, you have to do 5 or 10 other lookups to get descriptions or.
But at first, when we talk about the ISAM access scenario, a lot of this data is already cached inside, so there is not a strict correlation between each lookup and each request. There may happen worst cases, which this can happen, but it's still not that much. First thing. And that's when we are talking about just moving your ISAM data to the SQL Server and having a very bad worst case scenario like you described. But we can optimize this very easily. Then I will get back to you. Because what we can do is we can create a view, right? We can create a view of this where we say, okay, this is a view where we have table A data, table B, C, D, E data in the view definition, and then on the client station we just request the view. What that means is we just have one request for all subtables because the view is calculated on the server side and we are all set and perfectly fine. So the point I want to make here is, yes, we did as much as we can to increase performance and so on. And maybe there are worst case scenarios, but because we decided to have not ISAM and SQL in a competitive manner, we decided to have them completely transparent, integrated, which we always call hybrid approach. Xbase ++ is hybrid in any way. You can now use SQL features such as a view to optimize this scenario very well. So, yes, you had some question?
What happens when my customer wants me to use his Oracle database?
Well, then you are in deep trouble when it comes to the Postgres ISAM feature, because we have only been able to provide you that type of experience with that database server. We are not able to do the same for the Oracle eventually, because it has a lot of great features, but we are definitively not able to do that for Microsoft SQL or things like that. We concentrate here on this system with this unique feature.
But can I use Xbase 2.0 without the ISAM features?
Yeah, naturally, sure. I mean, if you don't want to have migrated your DBF table, you can use the upsizing wizard to do it in SQL mode. And when you do it in SQL mode, you're moving your DBF tables to the SQL server, and then you should use SQL to access that data. Huh?
Yes. Do I need an ODBC driver then?
You need to use the ODBC driver for the Oracle when you want to use the SQL. That's correct. Rachel?
Yeah, I'm just thinking of a real-time thing that we want to. Bobby's application here, the medallion system for the taxi cabs, it's got about 100 different databases. This is all in ads right now. It's got about 100
You mean
different
tables?
Yeah, tables. They're going to become, the databases, they're going to become tables, yeah. But we're not using SQL, just a little bit right now. And about 30 gigs of data. That's what it is right now. Okay. Let's say, have you made a little utility that will scan a directory? They're all CDXs. That will scan a directory and write that configuration file for you, so we don't have to enter all those.
No, we have not created that utility. But
okay.
but I think it's not so
You don't think
critical.
it'd take that long to do anyway by writing it in?
Yeah.
Okay.
And you can write that utility. I mean, creating that XML file is very straightforward.
Yeah, it's
So
very straightforward. I just wondered if you already created one.
Uh-huh.
And then, now we're looking at 30 gigs.
yeah,
Norm, do you say that it isn't necessary to do this migration on the server? You can do this on the client workstation. Isn't that right?
yeah.
So this 30 gigs of stuff will come over
No.
pretty fast.
Now, when you are migrating a data amount of 30 gig, I would propose to do it on the server
Do it all on
physically,
the server.
because 30 gig for a SQL Server system to work through is a bunch of data, and to do that over the wire, I wouldn't do that. I mean, you can do it if you have the time.
Yeah, okay. I thought you mentioned that this was optimized to be able to do it that way, you know, through all these threads that you sent it to. I wasn't sure that I understood that part.
We tried it. Our maximum data was 400 or 500 gigabytes, something like that.
Yeah.
Was the workload tests for this upsizing utility. You know. We didn't move into the terabyte scale with the
Yeah.
upsizing tool. Yeah. Okay, so Emily is obviously closing the session. Da-da-da-da.